In this video, we're going to examine integration, and we're going to use a partial fraction decomposition to make the integration easier for us. What we want to note about this example is that it is a proper fraction, meaning the degree of the numerator is linear, 1, which is less than the degree of the denominator, quadratic, or 2. And then we have a repeated factor. We have a linear factor squared. So we're not dealing with entirely unique factors. So our first step here is we look at this and we say, well, it's not very evident to us that we could work this using a U substitution or even integration by parts. Why don't we try decomposing this partial fraction? So I'm going to take my integrand, 6x plus 7 over x plus 2 quantity squared. And when we're dealing with a repeated factor, that means essentially I have x plus 2 times x plus 2. I'm going to write this out as a times x plus 2 plus b over x plus 2 quantity squared. So for example, just to clarify, if I'd had something and maybe it was over x plus 1 to the 5th, if I wanted to write that out to do my partial fraction decomposition, I'd have a over x plus 1 plus b over x plus 1 squared plus c over x plus 1 cubed plus d over x plus 1 to the 4th, and then plus e over x plus 1. We would have to do that 5 times to the 5th. Okay, so if we'd had 5 repeated factors, we would have many more terms listed here. You're not going to really see anything above a square. You might see cubed, but I really doubt it. Okay, so we're not trying to make that problem really large for you. So once I've written that out, now I'm going to multiply by my LCD, and my LCD is x plus 2 squared, or x plus 2 x plus 2. So if I multiply both sides by my LCD, I have 6x plus 7 over x plus 2 squared. I'm going to multiply that by x plus 2 squared equals a over x plus 2 times x plus 2 squared plus b over x plus 2 squared times x plus 2 squared. And that cancels factors. And it leaves us with 6x plus 7 equals a times x plus 2 plus b. Right? So we multiply by the LCD to clear the fractions, have everything written on one line. So now that we have this, our goal is to determine what a and b are. Essentially here I have 6x, right? Looking at my linear term, I have 6x, I have plus ax, and then b has no x with it. So 6x is equal to ax, and my constant 7, I have 2a plus 1b. So it's easy at this point for me to see that 6 equals a, and then I have 7 equals 2a plus b, or rather 7 equals 2 times 6 plus b, that's 12. We have negative 5 equals b. So again, we've got 6 is equal to a, and negative 5 equals b. Now that we've solved for a and b, and clearly that was much easier than the last problem we did, we're going to go back up and plug them in. So we had 6x plus 7 over x plus 2 squared equals, we had a over x plus 2 plus b over x plus 2 squared. And since we know what A is 6, and my B value is -5, that's going to change that to -5 over this quantity. So we started with the integral of this more complex rational expression, and now we've made this two smaller rational expressions. So we are being asked to integrate 6 over x plus 2 minus 5 over x plus 2 quantity squared dx. And since we know that the integral of the sum is the sum of the integrals, I can rewrite this, and again factoring out those coefficients, the integral of 1 over x plus 2 dx minus 5 times the integral of 1 over x plus 2 squared dx. So I have two integrations to do. This first one, let u equal x plus 2, and then du is equal to 1, or du over dx equals 1, so du equals dx. And that means we need to integrate 1 over u, which is, of course, the natural log of the absolute value of u. So for this first piece, I've got 6 times the natural log of the absolute value of x plus 2. Now, for the second piece that we're looking at here, we again are going to do a u substitution. Here I'm going to say let u equal x plus 2, and that means du equals dx, and we're dealing with the integral of 1 over u squared du. Now this one's not going to be natural log because we can use our power rule, so this is u to the -2 du. Integrating using the power rule, if I add 1 to -2, that gives me -1, or rather -u to the -1, or -1 over u. So I have -5, and I've got -1 over u. I'm going to go ahead and say -5 times -1, that's going to be +5. I'm going to slide that 5 into the numerator. So I'll say +5, we had it over u, which is x plus 2. And of course, we finish our indefinite integral by writing plus c. So in this example or this video, we talked about integrating using partial fraction decomposition as a tool, and the partial fraction decomposition that we performed, we had a repeated factor in the denominator. So we look at how we set that up. As always, email me if you have any questions.